Hello everyone and welcome to this comprehensive Generative AI course. And in this series, we will explore the revolutionary field of Generative AI, its evolution and the technologies driving it forward. From understanding what Generative AI is to hands-on projects, you will gain valuable insights and practical knowledge. But before we get started, please like, share and subscribe. Remember to hit the bell icon to stay updated on the latest tech content on the Edureka's YouTube channel. Also, check out the Generative AI certification courses on Generative AI in ChatGPT and advanced courses on Generative AI. The course link is given in the description box below. So, let's dive in and start with our agenda. We will touch on examples and applications of Generative AI, take a historical tour from 1900 to 2024, and then dive into how LLMs work with real-life examples. We will wrap up with useful tips and tricks and a small project to reinforce your learning, where we are going to create a medical image analysis application using Streamlit, Python and an LLM of Google Gemini AI. So, stay tuned until the end of this session. Now, let's answer the fundamental question, that is, what exactly is Generative AI? Generative AI refers to algorithm capable of creating new content, whether text, images, audio or even videos. It's like having a creative AI assistant that can take a simple input and produce engaging outputs. For example, GPT and Llama can write essays or code, while image generation models like DALL-E and Stable Diffusion can visualize unique scenes from descriptions. But let's look at some of the popular tools driving this innovation. Well, some of the standard tools in Generative AI includes GitHub Copilot, which assists developers with code suggestions, and ChatGPT for text-based interactions. Image generation tools like Stable Diffusion and Midjourney helps creators bring visual concepts to life. Google's Gemini merges text and image capabilities, while Adobe Firefly extends AI's reach to creative suites. So, if you want to know how to use these tools, then check out our Generative AI Examples video link in the description. So, you might wonder, where are these tools being applied? Now, let's explore them. Generative AI is transforming multiple creative fields. Image generation tools power visual design, music compositions algorithm create original scores, and AI assists video editors in automatic tasks. LLMs help generate and translate text, while code generation tools like GitHub Copilot boost developer efficiency. AI-generated voices are even being used in audiobooks and voice assistants. So now, let's take some of these tools and check. So this time, we will use Pictory AI and Flicky AI. First, let's explore Pictory AI. So for that, let's go to its site and check its functions. So, we are at the Pictory AI site. And on the left side, we have the home, project and brand kits. And on the main screen, we have different features Pictory AI provides. So, let's choose text to video. Here, let's write some names and description and press generate. Pictory AI is a tool designed for video creators that helps transform long-form content, such as articles or blog posts, into short, engaging videos. It uses AI to automatically extract key highlights and create professional-looking videos with minimal efforts. Due to its simplicity and time-saving capabilities, Pictory AI is popular for social media content creation and marketing. Now, let's see our next tool, which is Flicky AI. So now, we are at the Flicky.ai site. Here, we have different features like videos, where you can create videos from all of these blogs, prompts, etc. You can also create audios from these features, and then we also have a design feature. And on the left-hand side, you can see options like files, templates, brand kits, voice clones, etc. So now, let's take an idea and convert it into a video. Now, let's write our topic and generate. Flicky AI is a content creation tool that turns text into videos using AI-generated voices and visuals. It helps users create professional videos quickly by pairing written content with stock images, animations, and voiceovers. Flicky is ideal for marketers, content creators, and educators looking to create engaging video content efficiently. Now that we have seen the applications, so let's step back and look at the journey that brought us here. So basically, our journey starts in 1947 with Alan Turing's concept of intelligent machines. By 1961, Joseph Weissenbaum introduced ELIZA, the first chatbot. The 1980s saw the birth of recurrent neural networks, while 1997 brought long short-term memory networks to tackle sequential data. And then GANs emerged in 2014, transforming creative tasks. Fast forward to 2017 when transformers like GPT entered the scene. By 2023, GPT 3.5 and Google's PaLM marked significant milestones. And by 2025, we are on the brink of AI breakthroughs in chemistry and genome editing. So, what exactly are these LLMs and why are they so powerful? An LLM or large language models analyzes and understands natural language using machine learning. Examples include OpenAI's GPT, Google's PaLM, and Meta's Llama. These models drive applications such as chatbots, language translation, and more by learning from extensive data to predict and generate text sequences. But before this, there was a very famous term called language model. A language model is a machine learning model that uses probability statistics and mathematics to predict the next sequence of words. Suppose you have a sentence like, I have a boy who is my dash. Here, if we ask a language model to predict the next word, it considers the context provided by the words before the blank. Based on common usage patterns from its training data, it may predict words like boyfriend, brother, or friend, which fit naturally. However, it's less likely to predict colleague or sibling, as those words may not commonly follow this type of phrases. So this process shows how language models predict text by calculating probabilities for each possible word based on their likelihood in context. So, when a language model is trained on massive amounts of diverse text, it gains a wider vocabulary and more understanding of language, enabling it to make more accurate predictions. For example, if we give it a phrase like, you are a dash to me, a model trained on extensive data might suggest various fitting words, for example, friend, inspiration, or anything else. So based on this sentiment or context, it has learned from the data. Now here, reinforcement learning is used to improve the model's responses over time. By giving feedbacks, be it positive or negative on the responses, we help the model learn which type of responses are preferred in specific context. For example, if the model frequently misinterprets the tone or intent, the reinforcement learning helps adjust its predictions to be more contextually appropriate and aligned with the intended meaning. But what do these models look like under the hood? Well, LLMs are built on neural networks composed of input, hidden, and output layers. The hidden layer processes information to learn complex patterns, and more layers means the model can capture deeper insights. This structure allows LLMs to perform tasks from generating text to complex code completions. Now, how do these layers interact and function in real time? Now, LLM is based on the transformer, and a transformer uses deep learning to process any information coming to it. Now, let me tell you a story of three friends. Imagine we have three characters. First is our friend, the next character is Minion Bob, and the third character is Gru. So our friend asks Bob, what's the price of the jet? It must be $50,000. Minion Bob isn't sure, so he goes to Gru and asks, is the jet $50,000? Gru replies, no, it's $70,000. In this back and forth, Minion Bob is like the neural network layer trying to make an accurate guess. So each time he goes back to Gru, like receiving more data or feedback, he gets corrected if his guess is wrong, leading him to refine his response. Now, after the first check, Minion Bob returns to our friend saying, I guess it's more than $60,000. Our friend assumes it might be around $65,000 and sends Bob back to Gru to verify. Again, Gru corrects him, no, it's actually $70,000. So this process repeats with Bob adjusting his guess each time. Eventually, he learns that the correct answer is $70,000 and updates his knowledge. So, just like Minion Bob, neural networks make initial guesses based on available information. With each feedback loop, like Bob going back to Gru, the model's hidden layers adjust the parameters to refine its guesses, ultimately arriving at the most accurate prediction possible. So, After getting corrected multiple times, Minion Bob's guesses improve until he knows the price is $70,000. Similarly, in a neural network, gradually learning the correct answer through training. So, once the network learns, it can give accurate answers in future cases without checking every time. Now, let us move on to understand how LLMs work. LLMs begin the collection of datasets, then tokenize text and break it into manageable pieces. Using a transformer architecture, they process the data sequence all at once, leveraging vast training data. LLMs contain millions of learned parameters that predict the text tokens and generate coherent outputs. Models often undergo pre-training for general knowledge and fine-tuning for specific tasks. So now, let's see some practical uses of LLMs. LLMs power content generation, creating anything from articles to code. They excel in language translation, enhanced search engines, personalized recommendations, code development assistance, and sentiment analysis, which also owe much to LLM's predictive capabilities. So guys, are you ready to use all that knowledge in coding and witness how these LLMs come together to drive innovation? Whether through developing applications, analyzing data, or building smart assistants, the gear of technology keep turning to unlock AI's full potential. So now, let us look at our problem statement. So, one of the difficulties in the healthcare industry is effectively evaluating medical pictures such as MRIs, CT scans, and X-rays in order to identify anomalies and illnesses. This procedure takes a lot of time and calls for specialized understanding. Automated methods must be developed to help medical personnel recognize possible health problems in medical imaging. In order to provide better patient care, a system that integrates cutting-edge machine learning models with image analysis can greatly help in the early detection of diseases, including cancer, infections, and other illnesses. So the method uses generative AI to evaluate medical photos and generate a thorough diagnosis report based on the findings. This technology allows users to upload medical images, which the AI model then processes. Now, let us build our project on a medical image analysis application using Streamlit, Python, and an LLM of Google Gemini AI. So this app helps healthcare professionals analyze medical images such as X-rays, MRIs, and CT scans to detect anomalies and diseases. First, let's import the necessary libraries. So first, import Streamlit as ST. So if this is not working or showing an error, then open the terminal and write pip install Streamlit. And from pathlib, import path. Next, import google.generative AI as Gen AI. So, we are importing Streamlit for the app interface and path from pathlib for handling file paths and Google Generative AI, which allows us to interact with the Gemini AI model. Next, we will configure Google's Gemini API by setting up our API key. So this will allow us to connect to the AI model and generate insights from medical images. So before proceeding, let's get our API key and we will go to the Google to generate an API key. So on your left, there is an API key option and after clicking, you will get the Create API option. So just select your model and create your API key. So as you can see the screen, just copy this API key and go back to terminal. So now let's configure our model. So just type genai.configure and inside the bracket, give API underscore key equal to and over here paste the key. Now we set up the system prompt which defines the role of the AI model. So the prompt specifies that our AI is a medical image analysis system capable of detecting diseases like cancer, cardiovascular issues, neurological conditions and more. So guys, I have already researched the prompts and written here. So basically, the system prompt should be inside the triple quotes. So this prompt guides the model to analyze medical images for conditions such as cancer, fractures, infections and more making it a valuable tool for healthcare professionals. Now, let's configure the model settings for generating responses. We define parameters like temperature and top K to control the creativity of the model's output. So first type generation_config equal to, and inside the double quote we will give temperature, which is 1, then top_P, which is 0.95, next top_K, 40, then max_output_tokens, which is 8192. Next, response_mine_type, which is of text or plain. So over here, the temperature 1 that controls randomness, a value of 1 given balanced output diversity. Next, top P 0.95 uses nucleus sampling, selecting tokens from the top 25% cumulative probability distribution for diverse responses. Next, the top K 40, which limits token selection to the top 40 tokens based on the probability, narrowing possible outputs to high probability tokens. Next, max output token. This setting allows for longer responses by limiting the maximum length of the generated text to 8192 tokens. And then we have response mine type, which specifies the format of the output as plain text. So for more information, read the Google Gemini documentation. Next, we will also configure safety settings to ensure that the model doesn't generate harmful content. So for example, we block categories like harassment, hate speech, and sexual explicit content. Here, we are using two things. First, categories, and then the threshold. Then, copy this 4 times like harassment, hate speech, and sexual explicit content. Now, let's set up the layout for our streamlit application. So for that, we will configure the title and the layout of the page and even add a logo to make the interface more user-friendly. So first, type st.set_page_config, and inside the bracket let's give page_title equal to, and inside the double quotes we will give diagnostic analytics, comma, page_icon equal to robot. Now let us type column 1, comma, column 2, comma, column 3 is equal to st.columns, and inside the bracket give 1, 2, 1. 1, 2, 1. Next, with column 2, so I'll be using Edureka and medical images. So this will show you how to set up images using Streamlit. Now type st.image and give a bracket, and inside the double quotes let's type edureka.png and give a comma and give width is equal to 200. Now let us copy and paste it for medical. So let's type medical.png. Here we are using Streamlit's column to center the logo and title, and this makes the app look professional and visually appealing. Next, let's allow the user to upload medical images for analysis. So we use Streamlit's file uploader widget to accept image file in PNG, JPG or JPEG formats. So for that, let's type upload_file equal to st.file_uploader, and inside the bracket, inside the double quotes, let's type please upload the medical images for analysis, comma, type is equal to, so basically the image type is equal to, and inside the bracket, inside the double quotes, let's give PNG, comma, JPG and JPEG. Next, let us type submit_button equal to st.button, and inside the bracket, let's give generate image analysis. So here, when the user uploads a file and click the generate image analysis button, the model processes the image and prepare it for analysis. So once the user submits the image, we send it to the AI model for analysis, and then the model generates a response based on the prompt and image, which we then display in the app. So here, as you can see the screen, we have another function. So the if submit button, which runs the code when the submit button is pressed. Next, the image underscore data is equal to upload file.getValue. This actually gets the raw image data from the uploaded file. And next we have the image parts, where it creates a list with the image data in a structured format. Then we have the prompt parts. So this combines the image data and a text prompt for the model. So this part of the code actually sends the image and text prompt to the model to generate a response. And then we have the st.write, which displays the model's responses in the app. So here we use the image data and system prompts to generate content with the Gemini AI model. The result is displayed as a detailed report with insights about the medical image. Now it's time to test the code. So open the terminal and type streamlit run main.py. So once you enter, it will redirect you to our model interface. And there you go. So the model is ready. So here's a live demo of the app. We will upload a sample image and the app will analyze it and provide a detailed diagnosis based on the AI model's insight. So this is how we use Streamlit and Google's Gemini AI model to create a medical image analysis app. So this app can help medical practitioners by offering precise and thorough analysis of medical photos. Now it is the time for testing. So let's take one image of any disease and test it. So upload the image from your computer. Then we will select an image and press the generate button. So as you can see, it's running. So it generates fabulous response and can help doctors in assisting their patients, saving time and money. So this is how we built a real-time medical diagnostic helper using Streamlit, Python and Google Gemini AI. So with this, we have come to an end to this video on Generative AI course. And if you enjoyed listening to this video, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to the Edureka's YouTube channel to learn more. And happy learning!